6.2, the sixth question is in figure 6.21, A, comma, B and C are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that the BC is parallel to QR. So here, if you observe the figure, here PQR is a triangle, and ABC is also a triangle in it. So clearly mention that A, comma, B, comma, C are the points on OP, OQ and OR. Here A is a point on OP, B is a point on OQ and C is a point on OR respectively, such that AB is a parallel to PQ. Here given that AB is a parallel to PQ and AC is a parallel to PR, show that BC is a parallel to QR. We have to prove BC is a parallel to QR. To prove it, first of all, from triangle, I am taking this triangle POQ. From triangle POQ, clearly given that AB is a parallel to PQ. This is the given. So here AB is a line segment which is passing through two distinct points on two sides, and also AB is a parallel to PQ. So clearly we can say that PA by AO is equal to QB by BO, because here we use the basic proportionality theorem by BPT, basic proportionality theorem. So this is equation 1. And also from triangle, now I am taking the triangle POR. So from triangle POR, here given that AC is a parallel to PR. This is the given. So if you observe, AC is a parallel to PR and also AC line segment is a passing through two distinct points on other two sides. So here we use the basic proportionality theorem. We write PA by AO or OA is equal to RC by CO by using BPT, basic proportionality theorem. Let it be equation number 2. So from 1 and 2, we can say that here QB by BO is equal to PA by AO, and also RC by CO is equal to PA by AO. Here both terms are equal to the same terms. That's why here we can write QB by BO is equal to RC by CO. So this is what we get from the conclusion. Now from triangle QOR, QB by BO is equal to RC by CO. This is from 3. Here if you observe, here BC line segment passing through two distinct points on two sides of triangle QOB, and also we get the same ratio of the two sides. So we can write that BC is a parallel to QR by converse of BPT. Hence proved. That's it. Here the seventh question is using theorem 6.1, prove that A line drawn through the midpoint of one side of the triangle parallel to the another side bisects the third side. So here, if you observe the question, you can draw a figure by using the information. Let ABC is a triangle. In it, the midpoint of AB, let at D point. Here, a line is passing through the midpoint, which is parallel to BC. Which is parallel to BC. So here, let the point of intersection, the line at AC is let E. So this is the construction. Now we can write the construction. What we do then? Let ABC is a triangle and D is a midpoint on AB, and also DE line is a passing through a point on AC, passing through E on AC, and also clearly mentioned that is a parallel to third side. That means DE is a parallel to BC here. So now from triangle ABC, here D is a midpoint. So midpoint divides the line segment into two equal ratio. That means AD is equal to DB. Then AD by DB is equal to, we get 1. Let it be equation 1. So here, when a line is passing through two distinct points of the two sides of a triangle and it is a parallel to third side, we can say that by using theorem 6.1, that is a basic proportionality theorem, which is also that means the sides are is equal ratio. So that means here DE is a parallel to BC. That's why we can write that AD by DB is equal to AE by EC. So here we get the AD by DB as a 1. So we write 1 here. 1 is equal to AE by EC from 1. That means if you do cross multiplication, 1 into EC is equal to AE, 1 into EC gives you EC is equal to AE. So here clearly we find that the length of AE and the length of EC are equal. That means E is a midpoint. So when E is a midpoint, the line passing through the midpoint, that means that is bisects the third side. So it bisects the third side. Hence proved. That's it. Here the 8th question is using theorem 6.2 prove that the line joining the midpoint of any two sides of a triangle is a parallel to the third side. So here the theorem 6.2 states that if a line passing through the any two distinct points, that means any two distinct points, if the ratio of their sides are equal, then that line must be parallel to the third side. So that is nothing but the converse of basic proportionality theorem. So here, what is the basic proportionality theorem? Basic proportionality theorem is the theorem 6.1. So it mentions that a line is passing through two distinct points. If that is a parallel to the third side, then the ratios of those two sides are equal. That is the basic proportionality theorem. It is a converse of basic proportionality theorem. So here let A, B, C is a triangle. Here D comma E are the midpoints of AB and AC respectively. So if we draw a line segment through D to E, we have to prove that DE is must be parallel to the BC. So here solution, let ABC is a triangle and D comma E are the midpoints of AB and AC respectively. So when D is a midpoint of AB line segment, then we can write that AD by DB is equal to 1. How? Because AD is equal to DB. If we do cross multiplication or if we transfer DB to the LHS side, so AD by DB is equal to, it gives you 1 because D is a midpoint. Let it equation 1. And also E is a midpoint of AC line segment. That means AE by EC is equal to same 1. Why? Because of E is a midpoint. That's why AE is equal to EC. If you do cross multiplication, you will get AE by EC is equal to 1 here. So this is equation number 2. So from 1 and 2, we can say that AD by DB is equal to AE by EC because both terms are equal to the 1. So here AD by DB is equal to AE by EC. So from triangle ABC, we can say that AD by DB is equal to AE by EC when the ratios of the two sides are equal and this line segment passing through two distinct points of the two sides, then it must be parallel to the third side. That means DE is parallel to BC by using converse of DBT, basic proportionality theorem. That's it. Here the ninth question is ABCD is a triangle in which AB is parallel to DC and its diagonals intersected O. Show that AO by BO is equal to CO by DO. So here from the question we can draw a diagram. Here ABCD is a trapezium A, B, C, D, and also the diagonals intersect at O. So these are the diagonals intersect at O, and also AB is a parallel to DC. AB is a parallel to DC. Now draw a line parallel to AB. Let it be X, Y. Here the solution is draw a XY line parallel to AB, which is also parallel to CD or DC. So here from triangle ABC, here I am taking the triangle ABC. From it XY, so OY is the part of the XY, so OY is also parallel to AB. So this is from construction. from construction. So here XY is a parallel to AB. That's why OY is also parallel to AB. Here, when a line passing through two distinct points and also it is a parallel to third side, then clearly by using the basic proportionality theorem we can say that the ratio of other two sides are equal. That means AO by OC or CO. AO by CO is equal to BY by YC from or by BPT, basic proportionality theorem. Let it be equation 1. Now from triangle DBC, now I am taking this triangle. From it, here also OY is a parallel to CD or DC, whatever it may be, parallel. So this is also from construction. Here also, when a line is passing through two distinct points and also it is a parallel to third side, then the ratio of other two sides are equal. So that means BO by DO is equal to BY by YC. So here the ratio of other two sides is equal. That's why BO by DO is equal to BY by YC. So by basic proportionality theorem, by BPT. So let it be equation 2. From 1 and 2, we can write that here if you observe AO by CO is equal to BY by YC. Here also BO by DO is equal to BY by YC. Here both terms are equal to the same terms. That's why we can write that AO by CO is equal to BO by DO. Here it is. So here if you do the cross multiplication, you will get AO by AO into DO is equal to BO into CO. Now again if you transfer OD to that side and also BO to this side. So AO by BO is equal to CO by DO. So we can convert it into our requested form. So hence prove. That's it. Here the 10th question is the diagonal of a quadrilateral ABCD intersect at each other at a point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. Here, if you observe, we can draw a construction by using the given information. ABCD is a quadrilateral. ABCD. It is a quadrilateral in which the diagonals bisect at point O. Sorry, not the bisect, intersect. The diagonals intersect at O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. To prove, we have to make a construction. Here, draw a line which is parallel to AB, OA. So here, solution, draw OE which is parallel to AB. So from triangle ABC, I am taking the triangle ABC, I am taking this triangle. So here OE is parallel to AB and also it passing through two distinct points of other two sides. So the ratios of other two sides are equal by using basic proportionality theorem. That means CO by AO is equal to CE by BE. That is by BPT, basic proportionality theorem. Let it be 1. But clearly given that AO by BO is equal to CO by DO. If you change the positions, then you will get a OD by BO is equal to CO by AO. This is equation number 2. So from 1 and 2 we can write that, from 1 and 2 we can write that here CE by BE is equal to CO by AO, and also OD by BO is equal to CO by AO. So the both terms are equal to the same terms, that's why we can write CE by BE is equal to OD by BO. Let it be third equation. Now from triangle, now I am taking the triangle BDC. BDC. From triangle BDC, clearly we find that CE by BE is equal to OD by BO from 3. So from this triangle, here clearly if you observe, CE by BE is equal to OD by BO or OB. So here the ratio of other two sides are equal, and also the line passing through two distinct points of other two sides, then it must be parallel to the third side. It must be parallel to the third side. That means OE is a parallel to CD. What is it? It is a converse of a BPT by converse of BPT, basic proportionality theorem. So already we find that OE is a parallel to AB, and also it is a parallel to CD. So here OE is a parallel to AB and OE is a parallel to CD. Clearly we say that AB is a parallel to CD. So it is a trapezium. Hence that's it.